For those of you who may not know me, my name's Nick, and I'm going to do a quick demonstration of the FAST code. And for those of you who are interested in what the FAST code is, FAST is actually an acronym, and what it actually means is fatigue, aerodynamics, structures, and turbulence. FAST. So if anybody was interested in what that acronym meant, that's what that is. So just to start off, this is what you'll see in your when you open up FAST for the first time and download everything. This is the full FAST folder that you will see, and so I'll go through a little bit about how this thing how this program is compiled, and where the executable files are, and what other requirements that they need, and any other aspects to it that might be a little bit tricky at first, but I'll try to make things as simple as possible. So when you open up FAST, these are all of the this is the main folder of FAST, but the actual executable file is in the bin folder, which is one level in, and so depending on the type of system that you are operating, so whether it's a 32-bit or a 64-bit operating system, you will need to use a particular executable file in order to use this. So if you're using the FAST Win30, if you're using FAST on a Windows 32-bit operating system, I would suggest that you use the FAST Win32 executable file. You don't need to worry about the Win32D. That's not needed. And then if you're operating on a 64-bit operating system like I am, I would suggest using the FAST X64 executable file, and then you'll go from there. And requirements that they need, and any other aspects to it that might be a little bit tricky at first, but I'll try to make things as simple as possible. So when you open up FAST, these are all of the this is the main folder of FAST, but the actual executable file is in the bin folder, which is one level in, and so depending on the type of system that you are operating, so whether it's a 32-bit or a 64-bit operating system, you will need to use a particular executable file in order to use this. So if you're using the FAST Win30, if you're using FAST on a Windows 32-bit operating system, I would suggest that you use the FAST Win32 executable file. You don't need to worry about the Win32D. That's not needed. And then if you're operating on a 64-bit operating system like I am, I would suggest using the FAST X64 executable file, and then you'll go from there. And so what I would suggest that you also do is when you run the code, I would suggest copying this executable file as well as its respective map program, which is a DLL file, which acts as an application extension, because the executable file doesn't have all of the calculations that are needed in order to actually complete the code, and so it needs an extra extension and that you need to use when you start to compile the program. And so what I did here is when you copy the file over, you would copy it into the cert test folder, which is where all of your test files are in FAST. And there are 26 files. There are 26 different tests. I'll show you one of them, and just so you can become a little bit more familiar with the program. And one thing that I will also tell you about is that in the cert test file, in the cert test folder, there is an Excel sheet called Fast Cert Test Cases, and if you open that Excel file, it looks like this. And so, for the sake of the for the sake of this presentation, I'll just go through briefly what some of the models have been done before. So like there's an AWT, there's a UAE 6, an SWRT, and the NREL 5 megawatt turbine that a number of literature sources have used in order to fully compile this program, and a number of different pilot studies and case studies have been done using this particular turbine as well as some of these others. One thing in particular that I'll focus your attention on is the output, because when you compile this program and it compiles successfully, one thing that I would suggest is looking at what the output file is what types of output files are being generated when you run the program, because some output files can either be binary files, text files, or perhaps in some case studies it can generate both. And so what I would suggest is run the text files only, because if you try to open them in a program like Notepad or anything else, you won't be able to open it, you won't be able to read it, and it just looks really, really messy. And I would just suggest keeping it in the text file, so that way it's a lot more easier to read, it's a lot more easier to compile all the data that's needed in order to run fast. So like for example, I'll show you this particular case study, which is test number 18 in FAST, and I will show you how to compile this particular test. And one thing that I'll make note of here is that this particular output, its original untouched test file will generate a binary file, a binary output file. So I will go into it and show you how to switch from a binary file to a text file, and I'll do that right now. So if you go into this, if you go into the cert test folder and then go all the way down to test 18, you'll notice that there's an FST file and a CRU file. Open the FST file in Notepad. That's the easiest way to do this, because this is a text file. It's not a binary file, so that's why you can easily read the stuff that's in here. And so it'll show you all of the different types of input files that go into the program calls in order to run all the simulations and all of the different modules within FAST. And so like what was stated earlier, there's an inflow file program, so that's where the wind speed data comes in. There's the aero file, that's the Aerodyne, file, and then you also have the servo file, which is the Servodyne program, which is all the controls and things like that, versus Aerodyne, where that is the blade element momentum theory file and module that FAST can compute, just like Dr. Swift was mentioning earlier. And then of course you have Hydrodyne, and then you have Subdyne, which is substructural input parameters. If you wanted to see structural loading underneath the surface of the water, you can see that. There's mooring, and then there's also ice files. So you can actually simulate icing if you wanted to.